In this video, we're looking whether it's worth upgrading from the 3060 Ti, I have the Founders Edition, and this card is only an 8GB model, to the 5060 Ti that just launched. I am testing out the PNY dual fan model here, and this is the 16GB version of the 5060 Ti. This comes in an 8 and 16GB version, and I don't recommend buying the 8GB version. As you'll see in this video, if you have an 8GB card right now, you can make it work, like if you're still on a 3060 Ti, but I don't recommend buying a new 8GB graphics card in 2025 for the kinds of prices we're seeing on these things, especially if you might hang on to this to 5 or 6 years into the next console generation. Anyway, but the point is, if you're on a 3060 Ti and you still mostly just play online competitive games, here we're looking at Call of Duty Black Ops 6, and I did turn it down to the basic settings at 1080p because I think a lot of people do that for competitive edge. We're looking at 150 FPS versus 200 FPS. It's a 32% advantage for the newer card. It's noticeable, but it's not mind-blowing. If we move up to 1440p and stay at the basic settings for competitive gaming, we see the 3060 Ti can still handle 105 FPS in the built-in benchmark here. I can slide my fat head out of the way, and then the 5060 Ti 16GB is hitting 140 FPS. Again, 33% advantage. It's not nothing. It is something you could notice, but it's not like the 3060 Ti isn't getting the job done if this is the type of gaming that you're doing. In fact, at 1440p, it might make sense to kick on DLSS quality, which both of them can handle. Notice this is not frame generation in this particular test, because I don't think frame generation is appropriate to a multiplayer competitive game. While it does increase your frame rate, it's not decreasing the latency, which is what you're usually looking for in competitive titles. And whereas in a competitive game, you might even want to play at a frame rate above your monitor's max refresh rate for increased responsiveness, that doesn't make sense to do through frame generation, because that's not making the game respond to you quicker. Anyway, so the point is here we're using DLSS upscaling at the quality setting. The 3060 Ti can now hit 138 FPS versus 183 on the 5060 Ti, putting it 33% faster. But once again, the 3060 Ti for this kind of use case is still hanging in there pretty well. But again, there are different types of games out there. There's different types of gamers out there. You're interested in different things. So here, let's go ahead and test out all of the new stuff. So this is the Cyberpunk 2077. We're currently at 1080p. RT Overdrive, so this is path tracing. I am using DLSS 4, the new transformer model, at quality level upscaling, including the new ray reconstruction. And the 3060 Ti can't turn on the frame generation side of things, but the 5060 Ti can. So I'm showing it both in an apples to apples comparison here with frame gen off, but also in a ×4 frame gen mode. Now notice when we look at latency, the ×4 frame gen mode, despite producing a lot more frames than with frame gen off, is actually having a higher, by a little bit, you'd almost call it the same, but it is a few milliseconds higher latency than with frame gen off. This is why, again, I don't think frame gen is good for competitive titles. However, it does smooth out the motion fluidity on a high refresh rate display if you have a high enough base frame rate. And here we see the 5060 Ti 75% faster with frame gen off due to a lot of stuff. Let's actually back up for just 1 second there to talk a little bit about why is there such a big performance difference here than there was in the Call of Duty Black Ops game. So this is really highlighting everything that the 5060 Ti brings to the table from like a more VRAM perspective, from a feature set difference, architectural differences. One thing is that the ray reconstruction in the new transformer model, as well as just the normal transformer model upscaling with DLSS, runs a little better on the 50 series than it does on the 30 series, just due to some improvements to the architecture around those types of AI reconstruction accelerations. And that's without factoring in the frame gen differences. Another thing that doesn't factor in the frame gen differences is the VRAM capacity. This is using more than 8GB of VRAM here, and that is causing the 3060 Ti's performance to be lower than it otherwise would be. From a hardware perspective, it has some power, but having to spill into system memory reduces its performance compared to cards like this that have 16GB of VRAM. So that's all on a raw power perspective, and that's where we're seeing that 75% performance improvement generationally here in this test, but we didn't in the in like Call of Duty, for example. Now, also, again, we have the frame gen option, which I'm not factoring into that percentage difference. The 75% difference is without the frame generation. But again, if you're averaging around the mid 50 FPS range, kicking on frame generation can be a good experience. Again, it's not going to improve the responsiveness of the game. It will improve the motion fluidity if your display, refresh rate can go that high. And this would be a reasonable way to play this game. So again, this is kind of showing some things that come along with the 50 series update that I do think makes sense, but you don't necessarily see them if you're just playing the like Call of Duty style, online multiplayer games at low settings, that kind of thing. Now, it is important to note that if you're looking to do just native path tracing without any of the DLSS stuff, even the 5060 Ti is not really powerful enough for that. Here we're looking at RT overdrive mode with no upscaling, no frame generation, no ray reconstruction, none of that. We are seeing the 5060 Ti 35% faster, more in the 1% lows by 56%, because notice the 8GB card has these massive stutters. That's likely a VRAM spillover issue. But really, the 5060 Ti just isn't doing a good job here. It's only hitting 31 FPS versus 23 on the 3060 Ti. But even the 5060 Ti has 1% lows in the mid-20s, so I just don't think this would be a great way to play the game. Now, what if you're playing at 1440p? Well, again, the new DLSS 4 transformer model upscaling does look very usable, even going down to like quality or balanced mode. Actually, I think this is a mistake right there. That should be balanced mode. I apologize. I had to go down to balanced mode to get this to more playable frame rates, although I'd argue that this is still not particularly playable. Well, the 5060 Ti has a 69% advantage, nice, over the 3060 Ti at 44 FPS versus 26, and a bigger lead in the 1% lows, again, it's accentuated due to the VRAM issues on the 3060 Ti. Getting mid-40s is not an amazing gaming experience. It's playable if you want to do it, but it's not amazing. And using frame gen on top of that is increasing the latency pretty noticeably now. And so 130 FPS sounds good, but if you're doing it with ×4 frame gen, you got to divide that by 4 to get a better idea of how responsive that feels like, and I just don't think that's great. So while at 1080p, I felt like the 5060 Ti could maybe give a passable path tracing experience using DLSS quality. Even using DLSS balanced at 1440p didn't really make it a great path tracing GPUs. Now, again, you can play Cyberpunk with just not using path tracing or even ray tracing for that matter. So here, if we just look at 1080p Ultra, no ray tracing, both GPUs are actually giving you a great experience here. So you can definitely enjoy this game on the 3060 Ti. 90 FPS average here at 1080p Ultra. The 5060 Ti is 40% faster though at 126 FPS. So noticeably better experience on the 5060 Ti, but the 3060 Ti can still get the job done. At 1440p Ultra, the 5060 Ti expands its lead to 48%, hitting 80 FPS, whereas the 3060 Ti is at 54, which on a variable refresh rate display might be fine, but you might want to use upscaling or something to improve things. So if we take a look at that, what if we use DLSS, using the new DLSS 4 transformer model at balanced, and again, no frame gen at this point. The rest of the video is not going to test frame gen. I showed it once to kind of discuss my feelings on it. The video will be overly long if I included frame gen on every single game that we tested here. So DLSS 4 balanced upscaling with the new transformer model. The 3060 Ti is able to hit 77 FPS. And the image quality still looks pretty good using that model. The 5060 Ti at these settings is hitting 109 FPS, which gives it a 42% advantage. Now, there's definitely games where that VRAM difference makes a massively noticeable impact, like Indiana Jones and the Great Circle, where if you just try to boot the game at 1080p Supreme, which is the max non-path tracing settings, the 3060 Ti can't even boot the game with 8GB, whereas the 5060 Ti cruises right along at 99 FPS. If you do reduce the settings down to medium, then the 3060 Ti can hang in there okay at 90 FPS. However, if you play the game long enough, I've started to notice that it does start getting a stuttery frame time graph, and So even at medium settings, it can go a little over 8 gigabytes of VRAM at times and cause some problems, even though this short duration benchmark is not really seeing that in a particularly noticeable way. It's a 38% advantage for the 5060 Ti here. At 1440p Supreme, it's no surprise that the 3060 Ti is dead again, because again, the game just won't run on 8 gigabytes of VRAM at these settings, whereas the 5060 Ti is still just cruising right along at 77 FPS, 70 in the 1% lows. It's a nice flat frame time graph. This is really a well-optimized game if you have enough VRAM for the settings that you're using. If we drop down to medium settings, we can see the 3060 Ti is starting to get stutters in the frame time graph. So while it is running the game now and averaging 65 FPS, you can see those regular spikes on the frame time graph, leading a 1% lows differential here to be by 78%, even though the average frame rate difference is only 43%. So again, that 8 gigabytes of VRAM really might need low settings in the game, or at least low texture settings in the game. Another game where I'm seeing some VRAM-related issues and kind of a not so great results for the 8 gigabyte card is Final Fantasy 16. At 1080p Ultra, we're seeing a 52% lead for the 5060 Ti here at 73 versus 48. And again, some of that difference is due to the 8 gigabyte card having to slow down as it's going over the VRAM buffer, and it needs to pull things from system memory. Dropping down to medium settings doesn't completely solve the issue, although it improves it, and the 5060 Ti is now ahead by 41% at 97 versus 69. Nice. And if we go up to 1440p Ultra, again, the 3060 Ti just can't handle it. It's down at 36 FPS, whereas the 5060 Ti is honestly not doing amazingly well at 50 FPS itself. 39% advantage, but a 52% advantage in the 1% lows. Again, a place where the reaching into system memory is especially impacting the stuttering in the frame times, and that's showing up in the 1% lows for the 8 gigabyte card. Interestingly, if you kick on DLSS quality, things actually get kind of worse for the 3060 Ti. Its overall averages can improve a bit, but the 1% lows get even worse, and there's larger spikes in the frame time graph. Sometimes running out of VRAM can behave weirdly, and I think here, by DLSS, using DLSS here, the card's trying to run faster, but then that's getting even more held back by trying to reach into system memory, whereas the 16 gigabyte card doesn't have that problem, hits 74 FPS and wins by 72%. At 1440p medium settings, again, the averages are only showing a 41% difference at 65 versus 46, but if you look at the 1% lows, there's definitely still an issue with the 8 gigabyte card. You can see the frame time graph with these massive stuttery spikes. It's very noticeable in actual gameplay. The 1% lows are only at 18 versus 54, so that's 3 times the 1% lows if you want to look at it that way. But I really think the frame time graph is the best way to see the issue. Note that again, even using DLSS quality on the medium settings at 1440p still doesn't fit nicely in the 8 gigabyte VRAM buffer. So while the 3060 Ti averages 62 FPS, you can see it's still having those spikes on the frame time graph, so its 1% lows are only 28. The 5060 Ti just performs better overall, and the averages by 60% at 99 versus 62, and by 2.68 times the 1% lows at 75 versus 28. Let's test out some Unreal Engine 5 games. In Silent Hill 2 at 1080p epic settings with ray tracing turned on, the 5060 Ti is 34% ahead at 60 FPS versus 42. And at 1080p medium settings, the 3060 Ti is now able to get around 60 FPS in this game, so you can still enjoy this game on this card. These are just probably more like the settings you would use. And at these settings, the 5060 Ti is able to hit 93 FPS, giving it a 48% advantage. Moving up to 1440p resolution at epic settings with ray tracing turned on, the 3060 Ti is only hitting 29 FPS, whereas the 5060 Ti is 41% better, but that is only hitting 41 FPS. There's also a larger difference in the 1% lows, indicating that there's likely some VRAM spillover going on, manifesting in those 1% lows a little bit on the 8 gigabyte card. Anyway, I don't think these are really the settings you'd use on either GPU since frame rates are pretty low here. So if we kick on DLSS quality, the 3060 Ti jumps to 44 FPS. Playable if you wanted to, probably adjust settings more from there in my tastes, whereas the 5060 Ti could definitely play here at 65 FPS. It's a 48% advantage. If we just drop all the way down to medium settings with no DLSS, we actually see similar performance results to what we saw at the max settings with DLSS. gets the 3060 Ti to 47 FPS and the 5060 Ti to 65. 38% advantage for the newer card, but we can kick on DLSS off of the medium settings as a baseline, and now the 3060 Ti is giving you a perfectly reasonable experience at 58 FPS, and this is a pretty slow-paced game. You could play it here. So again, you can make the 3060 Ti work even in a big, demanding Unreal Engine 5 new release on a 1440p display. You just have to be at, medium settings DLSS. Now, the 5060 Ti is hitting 90 FPS, giving it a 55% advantage here, and definitely a much smoother experience. Another Unreal Engine 5 game we can test out is Hellblade 2. The high settings in this game are the highest settings in the game. There's nothing above that. And the 5060 Ti can handle 1080p max settings just fine at 71 FPS, putting it 51% ahead of the 3060 Ti, which is hitting 47. Now, this is an extremely slow-paced game, so 47 FPS is arguably usable here if you wanted to. It's a lot of just slowly walking and looking at things. But if you want more like a 60 FPS experience on the 3060 Ti, one option is to go to medium settings. The medium settings still capture the overall look of the game, still looks great, and the 3060 Ti is now hitting 66 FPS. 5060 Ti at these settings is hitting 92, which gives it a 39% advantage. At 1440p high settings, the 3060 Ti is only hitting 34 FPS, whereas the 5060 Ti hits 50. It's a 47% advantage, and this slow-paced of a game on a variable refresh rate display, 50 FPS might be a reasonable way to play. However, you could kick on DLSS quality on both GPUs, and that might be a better way to play given the big performance boost you get in Unreal Engine 5 when using DLSS. Here, the 3060 Ti jumps to 53 FPS, and this is now a very reasonable way to play the game on a variable refresh rate display. And the 5060 Ti is hitting 78 FPS, which is a 47% advantage and certainly a much smoother experience. At 1440p, you could also just drop to medium settings. This gets the 3060 Ti to 49 FPS and the 5060 Ti to 66. 35% advantage for the newer card. And again, reasonable playable frame rates on both GPUs, but if you want a higher refresh rate experience, you can use DLSS quality on the medium setting preset, and now the 3060 Ti is cruising right along at 71 FPS, even on a 1440p display, even in a big Unreal Engine 5 game. The 5060 Ti is hitting 99 FPS though, so certainly noticeably smoother and a 39% advantage. Not every game runs super well on the 5060 Ti, though. Ghost of Tsushima is a bit of a trouble spot I noticed in my testing. At 1080p very high, it hits 89 FPS, so it's fine, but it's only 24% ahead of the 3060 Ti, and I want you to look right here as we come up the stairs. Look at the fire. It's weirdly flickering, so this game is performing lower than expected and is having some graphical glitches on the 5060 Ti. So that's just something to be aware of, probably get dealt with in a driver update. And but for, currently this seems to be a bit of a low point for the 5060 Ti in my test suite. Now, here we see at 1080p medium settings, both GPUs can offer you over 100 FPS, 101 in the 3060 Ti's case, but 128 in the 5060 Ti's case, giving it a 27% advantage. And again, that flickering is still present. At 1440p max settings, which are called very high in this game, again, the flickering is still present when you look at the fire, the light right there in the fire. But the 5060 Ti is able to average 63 FPS, which is only 19% faster than the 3060 Ti's 53 FPS. Now, both of them could use DLSS quality to improve performance, and that pushes the 5060 Ti to 92, which is 28% faster than the 3060 Ti, which is hitting 72. Both of them are very usable here, although once again, seeing that flickering, glitching issue on the 5060 Ti. At 1440p medium settings, we're seeing a 19% advantage again for the 5060 Ti at 86 versus 72. Very realistic way you could play the game here on both cards. Again, seeing the flickering issue on the 5060 Ti. And we could go to DLSS quality on the medium settings at 1440p to get a nice higher refresh rate experience on both GPUs. 100 FPS on the 3060 Ti, 133 on the 5060 Ti, making it 33% faster. That one's easy to calculate. Let's look at Horizon Forbidden West at 1080p max settings. The 5060 Ti is good for 89, and the 3060 Ti is good for 65. If we go to medium settings, Both GPUs offer a much higher refresh rate experience at 93 and 123 respectively. That's a 32% advantage for the newer card. And at 1440p very high, the 5060 Ti is 28% faster than the 3060 Ti at 64 versus 50. And the using DLSS gets performance up to 89 versus 64, a 39% advantage for the 5060 Ti. If we drop to medium settings at 1440p, the GPUs can hit 87 and 66 respectively, so good experience on both, 32% advantage for the newer card. And using DLSS on the medium settings gets decently high refresh rate experience even on the 3060 Ti, hitting 89. The 5060 Ti hits 117 at a 31% performance advantage. And we could test out God of War Ragnarok 1080p Ultra. The 3060 Ti is averaging over 60 FPS at 63, whereas the 5060 Ti hits 84, 33% advantage. But you could drop to medium settings, and now even the 3060 Ti hits 88 FPS on average, and the 5060 Ti hits 110, giving it a 25% advantage, and a nice smooth experience on both GPUs. At 1440p Ultra settings, we're looking at 66 versus 50, so 32% advantage for the newer card. But again, you could use DLSS or reduce settings. At DLSS quality, we get to 87 FPS versus 67, which is a 30% advantage for the 5060 Ti. And still a very usable experience on the 3060 Ti. And going to 1440p medium settings, we hit 88 versus 69. Nice, which is a 28% advantage for the 5060 Ti. Good experience on both cards. And you could stack DLSS on top of the medium settings, and that boosts frame rates to 90 and 115 respectively. 28% advantage for the newer card. And so again, an example of if you play it on a 1440p display, the 3060 Ti at medium settings with DLSS quality is still really offering a very reasonable experience in a lot of games. So that's all the tests that I ran. That was a lot. Let's pop out for some analysis. So this chart summarizes the percentage advantage for the 5060 Ti 16GB against the 3060 Ti in all of the tests that I ran. It was about 50 tests or so. And the average result is a 39% advantage for the 5060 Ti. The raw power, if you weren't spilling over VRAM in any games, would probably average a little bit less than that. But again, the 16GB advantage is a very real advantage. But when we look at these larger performance differences, these are mostly showing up in situations where identified the game as wanting more than 8GB of VRAM. And so that kind of accentuating the performance difference between the two GPUs. Whereas if they're both running a test that is appropriate to 8GB of VRAM, the raw power uplift is probably a bit less than 39%. But I really do think one of the most compelling advantages of going to the 16GB 5060 Ti is getting the 16GB instead of the 8, because we did see in multiple games 8GB can cause a bit of a headache. And these are also short test runs. Oftentimes, if you play a game for longer periods of time, it will spill over 8GB of VRAM when it didn't in a short little 1-minute benchmark pass. So that's another thing to keep in mind. Anyway, what do I make of this overall? Well, to be honest, kind of depends on what price you can find the 5060 Ti for. Because if we're looking at should you upgrade from a 3060 Ti to a 5060 Ti 16GB, I would say that, well, if I tried to buy one right now, the couple models that are left in stock are either almost $500 or over $500. And that's not super exciting. Like I could show, so let's put it this way. The 3060 Ti launched for $400 a number of years ago. Now, if you multiply it by our performance uplift of 1.39, you'd get $550-ish. In other words, for complete stagnation, zero improvement in performance per dollar, the 5060 Ti should be priced at $550 to basically match the performance per dollar that you got from the 3060 Ti 2 generations ago. Now, obviously that's ignoring inflation and all sorts of things. It's really rough math. But the point is, if you're seeing these things in stock for around $550, it really makes you question the point of upgrading years later. Now, its MSRP is meant to be about $430, in which case it's getting you a little more noticeable of, it might have been worth, hanging on for a few years to upgrade. However, in the current market, since the current market isn't really great right now for upgrading, I do always like to encourage people to consider hanging on to the graphics card you have if it's still getting the job done. If it's not getting the job done for your use case, then, consider upgrading, even if the prices aren't amazing. But again, like I said, in a lot of games, if you went down to medium settings with DLSS quality, even on a 1440p display, the 3060 Ti was often still either averaging at least 60-ish FPS or in the lighter games, still fairly high refresh rate experience. And honestly, most games these days at medium settings with DLSS quality on a 1440p display still look very reasonable. Now, it's a bit annoying to have to battle that 8GB VRAM buffer and to have to turn down more settings and things like that. But if you can get by on the 3060 Ti, another generation, maybe we'll get more out of it in the future. What I think overall of a 39% uplift 2 generations later is a little bit of disappointment because, really, considering a 2-generation gap, that is not a mind-blowing performance uplift. It's and if you bought the 8GB model, you wouldn't even be getting these advantages of the 16GB VRAM thing. So, I don't hate the 16GB version of the 5060 Ti if you can find it anywhere near its $430 MSRP, which is the big elephant in the room. It's really not a massive 2-generation uplift from the 3060 Ti. I think a lot of that is hidden by the fact that the 4060 Ti, which was such a small uplift over the 3060 Ti, that while the 5060 Ti took a bigger generational uplift compared to the 4060 Ti than the 4060 Ti did compared to the 3060 Ti, it's when you go back to comparing to the 3060 Ti, it is better, and it is noticeably better, but for 2 generations later, you would hope for, almost doubling performance, honestly. But anyway, guess those days are gone. Now, the 5060 Ti can get the job done in most of the games we tested here. The only thing I felt like it was particularly underwhelming for was trying to do the 1440p path tracing, because I didn't really think like the frame generation could save the day, mostly due to the base frame rate being low enough that I didn't find frame gen super compelling here. Although I do find frame gen a nice feature, and I did think that when your base frame rates were high enough, like when we looked at the 1080p results, where you could at least get in the mid-50s before kicking on frame gen, then I did feel like it was a bit more compelling. So at 1080p, it's a little more passable for the more demanding ray tracing workloads. At 1440p, I think it's still just a little underpowered for that. But it is nice to get the support for frame gen and all of that, again, as another nice feature set move for the 50 series versus the 30 series, which to get frame gen support has to use third-party apps like lossless scaling or use AMD frame generation if it's built into games, which isn't always compatible with DLSS upscaling. So anyway, there's certainly some nice things if you do move to the 5060 Ti, and if you can get it near its MSRP, I don't think it's a bad upgrade to make. But like I said, if it's anywhere at inflated prices near $500, I think that if you're already on a 3060 Ti, medium settings with DLSS quality might be a way to get you through till the 60 series. Hopefully you guys found the video useful and or interesting. Huge thank you to viewers, commenters, subscribers, people who hit the join button to directly support the channel financially. Huge thank you to those folks. And I do, as a thank you, make like the side-by-side footage was available a couple of days ago because I hadn't filmed the voiceover that I'm filming now because I need to make the charts and it takes time to film and upload and make a thumbnail and all of that. So I do give some like early access to like the side-by-side footage and whatnot as a thanks to people who do click the join button. Anyway, huge thanks if you do. No worries if you don't. And I hope all of you have an excellent day.